Hello students, today we are going to discuss the properties of amines, physical properties and chemical properties. In the last class already we have discussed regarding the preparation of amines, aromatic amines and aliphatic amines. Now we will discuss the properties. Properties in this first let us discuss the physical properties. Physical nature. If you see physical property amines generally has lower boiling point than alcohol, BP boiling point, because oxygen is more electronegative. That's why ROH is more polar than amines, and the intermolecular hydrogen bond is stronger in case of alcohol. That's why alcohol has higher boiling point than amines. Then if you compare in between the amines, the having same carbon atoms, then the primary amines has higher boiling point than secondary amine, then tertiary amines. Because tertiary amine, it cannot form the stronger intermolecular hydrogen bond because it has no polar hydrogen attached to nitrogen. But in all primary, this is primary and secondary they have, but it has more number of hydrogen bonding compared to secondary. Tertiary has no intermolecular hydrogen bonding, that's why it has a low boiling point. So this is a very important difference between primary, secondary and tertiary amine on the basis of their boiling point. Then solubility, if you see that all amines solubles, water soluble due to hydrogen bonding. But solubility, if you see the concept, primary amine generally more soluble than secondary amine than tertiary amine. This is the solubility because on the basis of hydrogen bonding. So primary amines are more soluble than secondary amine than tertiary amine. So this is regarding the solubility and boiling point. And another thing, amines are also base. All amines and amine derivatives, these behaves as basic. All three behave as basic nature, because due to availability of lone pair on the nitrogen. That's why these behave as a base. But if you compare the basic character of amines, aliphatic amines and aromatic amines, if you compare that your aromatic amines, these are aniline. If you see, aromatic amines are less basic than aliphatic amines. These are less basic than aliphatic amines because aromatic amines had resonance. Due to deactivation, we can say that due to the resonance, the electron density of nitrogen decreases and it forms pi bond with the benzene. That's why electron density decreases. That's why it is less basic. This is the concept. But in case of amines, all having cross effect. That's why it is more basic than the aniline. First point is it has resonance. Due to resonance, electron density decreases. So it is the availability of lone pair nitrogen decreases, less available. That's why less basic than the amines. And it is also generally this is regarding. We'll compare the other thing little, the acidic character, basic character of amines. Also we can compare this thing that in case of, if you see that secondary amine, if you see comparison, you see the first point. Second thing is that secondary amine is more basic than tertiary amine. Primary amine is more basic than tertiary amine. And then last one is ammonia. But here, if you see the basic character, but in case this is the in aqueous medium, this is under aqueous state. This condition is aqueous state. But in vapor phase order is R3N is more basic than R2NH is more basic than RNH2. This is vapor phase. First one is aqueous phase. Aqueous phase, vapor phase only depends upon cross effect. As tertiary amine has more cross effect, that's why more basic. Because we know cross effect increases basic character. That's why tertiary amine is more basic than secondary amine than primary amine. But in case of aqueous medium, there are three factors are taken into consideration for the basic character. First character is that is cross effect. More cross effect, more basic character. That is directly proportional to basic nature. Then second factor is that is solvation effect. Solvation effect also directly proportional to basic nature. Third one is steric factor. Steric effect is inversely proportional to basic character. So these three factors is very important. One is cross effect, more basic character, more solvation effect. More solvation effect means after accepting H plus, then the hydrogen bonding, number of hydrogen bonding increases. That's a solvation effect also very important in basic character. Steric factor, if steric factor is more, then bulkier group, there will be steric hindrance, the electron pair on the nitrogen atom will not be, the electron density will not be more, because due to steric effect the molecule will be disturbed. So that's why steric factor decreases basic character, these three. So if you take that tertiary amine, that secondary amine is more basic than your primary amine, taking methyl group, than your tertiary amine. This is in aqueous medium. Here what happens? Here cross effect is more compared to steric factor. Here cross effect is more compared to steric factor. But here what happens in case of tertiary amine, the steric factor is more in case of aqueous medium. This is only in case of aqueous medium. In aqueous medium, the order is secondary. This is your secondary, greater than primary, greater than tertiary. Because in case of tertiary, what happens? Steric factor is more. As steric factor is more, so basic character is least. And here steric factor is more, then another is solvation effect is less, because it has no hydrogen attached to nitrogen. So low solvation effect and more steric factor. That's why basic character of tertiary amine is least. Very important, this thing you remember. But if you change methyl by ethyl, the factor will be very important, this thing. In case of ethyl, basic character will be different. Here what happens? You see, here what happens in case of ethyl, that here if you see this, here cross effect is more predominant. Here cross effect is more favorable. That's why tertiary amine is more basic than primary amine. But in you taking the methyl group, tertiary amine is less basic than primary amine. So this is a very important comparison between that primary amine, secondary and tertiary amine, their basic nature. Then already discussed that aromatic amine is less basic than what? Amines, because in case of aromatic amines, the resonance takes place, so electron density nitrogen decreases. So more basic character means more, because so if you compare this one, more, you remember this thing very important, more basic, less pKb, less pKb. This thing you remember, but more pKb, more kb, more kb but less pKb. This comparison, this concept already know. Higher basic character, higher kb value, but a lower pKb value. This concept already know. Then we will discuss some important properties of amines. First one, that chemical properties. Chemical properties. If you discuss chemical properties, first we know amines reacts with, all amines react with, that is soluble in acids, forming salt. This is your amines. Amines becomes producing salt. That means amines soluble in dilute HCl. Why amines are soluble in dilute HCl? Because it produces salt, RNSD plus Cl minus. This salt is produced. That means that's why it is water soluble, or it is acidic medium. It is soluble. Then this, if you see that other properties that already know, this is the first. Then the second one, that amine, already we have read, amines reacts with haloalkane, producing secondary amine plus tertiary amine plus quaternary salt. Already we have discussed in that in the preparation of amines, and this reaction is called Hofmann ammonolysis. This is called Hofmann ammonolysis, formation of primary, secondary, tertiary amine. But as you have taken primary amine, this is primary amine, so we get secondary, tertiary and quaternary salt. We get this reaction is called Hofmann ammonolysis, and this reaction also takes place in case of acylation. If you take primary amine with acid halide, any acid halide if you use, the result will be acylation. This reaction takes place in presence of base. The result is RCO. Here it will attack RCO. What happens? RCONHR. This product is produced. Then HX. This is amide. Amide is produced. Amine becomes amide. Amide derivative will produce. So this is very important reaction of amines with acid halide, acid anhydride. Both reaction takes place. Then another important reaction of amines, that is called carbylamine reaction. Carbylamine reaction. This reaction is shown by both aromatic and aliphatic amines. If you take RNS2 in presence of chloroform and base KOH, result is unwarming. Result is RNC plus KCl plus water. And this RNC, that is called isonitrile. This is also called as that carbylamine. This is called carbylamine. Carbylamine. Formation of carbylamine, observe as a foul smell. foul smell, order, foul smell observation we get that indicates formation of isocyanide. RNC is called isocyanide, it is also called carbureting. This is very important test of amines. Amine, that is only primary amine. Primary amine shows this carbureting reaction, presence of primary amine, or your aromatic amines also. Aromatic amines also give this reaction, RNS2 plus CH3 and KOH produce NC plus KCl plus water. This also indicates as a foul smelling substance. So this indicates the presence of primary amines. So this is carbureting reaction. Amines also, amines when reacts with that diazotization occurs when RNS2 react with sodium nitrite and HCl, that you can say nitrous acid. When you add nitrous acid, that we can add sodium nitrite and HCl, it will produce diazonium salt Rn2 plus Cl minus. But this Rn2 plus Cl minus is very unstable. It is unstable. It undergo hydrolysis in presence of water forming alcohol. So very important that primary amines produce alcohol. But if you take secondary amine, it will produce, if you use secondary amine, same nitrous acid, it will produce nitrosoamine. It will produce nitrosoamine. Nitrosoamine is formed. This indicates reaction of tertiary amines. And secondary amine, this is your secondary amine. And tertiary amine produce, if you take tertiary amines with HNO2, produce R3N, NH plus and NO2 minus. This salt, tertiary nitrite, that tertiary derivative of nitrite of tertiary amine is from you see R3N having lone pair, it will accept one H plus, then R3NH plus, then NO2 remains. So this type of salt will produce. This salt is produced. And secondary amine produce nitrosoamine. It will produce nitrosoamine. Then it may be NOH. It may be NOH also converted to like this. Anyway, different types of amine, primary amine, secondary amine, tertiary amine reacts with nitrous acid, producing alcohol, nitrosoamine, and salt. So this is some important reaction. Then you complete this one. Then I will erase this your board. Okay, finish it. Similarly, if you take aniline with nitrous acid, produce diazonium salt, N2 plus Cl-. This is called BDC, benzene diazonium chloride. This is stable. This salt is stable. Okay. So, but aliphatic amine, RNS2 with nitrous acid produce that diazonium salt, which is unstable, can easily hydrolyze, produce alcohol. So, aniline in presence of nitrous acid produce BDC. This reaction is called that diazotization. This is called diazotization reaction. diazotization reaction, and this diazotization reaction means formation of diazonium salt from aniline. Okay, aniline or amines can be distinction. If you see distinction of amines, if you do distinction of amines means primary, secondary, tertiary amine can be distinguished by the reagent is Hinsberg reagent. Hinsberg reagent. If you take primary amine, aniline also give this reaction. Primary amine first reacts with the Hinsberg reagent C6H5SO2Cl. This is called benzene sulfonyl chloride. This is called Hinsberg reagent. First produce insoluble salt, you can say, that derivative, that NHSO2 C6H5 plus HCl. It is soluble, insoluble mass or precipitate is obtained. That amine with benzene sulfonyl chloride produce insoluble mass, that substitution of amine, that nitrogen, to the sulfur having electron deficient. That's why it acts as nucleophilic substitution. This reaction is called nucleophilic substitution, formation of insoluble mass appear as a precipitate. And this precipitate, when treated with KOH, that is base, again it is soluble in the form of RNK, then SO2 C6H5, soluble. This insoluble mass will be soluble in base KOH. This is the indication of primary amine. Similarly, if you take secondary amine, R2NH, in presence of C6H5SO2Cl, then what happens? This produce insoluble mass R2N, then SO2 C6H5, it is insoluble. That means both combined for the insoluble mass. And if you add base KOH, there will be no change because it has no acidic hydrogen. Here this hydrogen acidic because due to presence of sulfonyl group. Sulfonyl group is electron withdrawing group. That's why this H is acidic character. So that's why forming the salt. In soluble salt, you can write soluble salt. But here, as it has no, after the first step, that insoluble mass is produced. It will not be dissolved in KOH, will not dissolve because it has no acidic hydrogen. That's why secondary amine gives only insoluble mass but no reaction with KOH. In this way, you can distinguish primary and secondary. And the tertiary amine, if you use R3N with C6H5SO2Cl, there will be no reaction because it has no acidic hydrogen. That means it has no hydrogen attached to nitrogen. That's why there will be no substitution reaction. That's why tertiary amine do not react with Hinsberg reagent. But primary amine, secondary amine gives the reaction. First one, the insoluble mass produced will be dissolved in KOH, but secondary amine, that insoluble mass will produce will be insoluble in KOH. This is the difference between primary and tertiary amine using Hinsberg reagent. Then another important reaction of we can say now we'll discuss some electrophilic substitution reaction of aromatic amines. electrophilic substitution reaction. Electrophilic substitution reaction. Electrophilic substitution reaction already know as amine. We know this one. Amine, it has resonance. This amino group also acts as electron donor. It activates the ring and forming that ortho position and para position more electron density. So it produce ortho para substituted product. It reacts with electrophile forming ortho para substituted product. So if you use aniline, with the bromine water, the product will be like your phenol, both ortho, para, all gets substituted, and that is 2, 3, 1, 2, 3, 4, 5, 6. So 2, 4 and 6 tribromo aniline produce, which is obtained as white color, white mass obtained. That is also one important test of aniline. Aniline, when treated with bromine water, produce white mass of 2, 4, 6 tribromo aniline derivatives, orthopara derivatives. But it is being observed, this reaction is very slow generally, but the reaction generally as amino group here as if we use nitration before reaction of aniline, electrophilic substitution reaction of aniline, that is your nitration bromination reaction, it should be acylated. First it reacts with acid halide or acid anhydride, either acid anhydride or react with acid halide, forming acylation, produce acylation NHCOCH3. Due to the acylation, the amino, the lone pair electron will be attracted by keto group. That's why what happens, this as it is this lone pair will not available on the nitrogen atom, that's why it will not easily oxidize. So to prevent oxidation, the aniline should be acylated. This is called acylation. Reaction. Before nitration bromination reaction of aniline, the aniline should be acylated because to protect the oxidation of aniline. That's why when it will be acylated, the lone pair nitrogen will be trapped by keto group, that carbonyl group. That's why it will not easily oxidize. Then it gives the electrophilic substitution reaction by nitration or bromination. So this is very important. Before nitration, to prevent oxidation, aniline should be acylated by using acid halide or acid anhydride. Then if direct nitration will be used, if you use direct nitration, what happens? It will produce anilinium salt. It will produce NH3 plus and NO3 minus. This produces anilinium salt. This is called anilinium salt. Due to formation of anilinium salt, it gives both products, that ortho, meta and para product. will produce aniline derivative NH2 ortho plus NO2 NH2 para, and also it will produce meta, and your para product is 51%. This is your 51%. This is your 47%. This is your 2%. So both mixture of ortho para meta trinitro, that ortho meta para nitro aniline will be produced due to oxidation of aniline by nitric acid. So to prevent the formation of ortho para meta, it should be acylated. After acylation, if you use with nitration reaction, then the product will be nitration, then followed by hydrolysis. Product will be ortho nitration, then para. But para is the major product. This is your minor product. Ortho para, pure ortho para product will be obtained if it will be acylated. Before acylation, if you use direct nitration, then you will get a mixture of ortho para nitration due to formation of salt. Because anilinium ion which is produced is prevent the attack of electrophile at ortho and para position. That's why both ortho position will be totally prevented. So only para and ortho product, para, that is meta, and para product will be more. So before nitration, it will be acylated. Then very important thing is that aniline does not give Friedel-Crafts reaction. This is very important. Aniline C6H5NH2 does not give Friedel-Crafts acylation reaction or alkylation reaction. Friedel-Crafts alkylation acylation reaction is not shown by aniline, because when aniline will be treated with ferric chloride, thus suppose aluminum chloride is used in acylation and alkylation, it producing a salt. This salt is that between aniline and aluminum chloride, because it is electron acceptor, it is electron donor. So what happens? It donates electron to aluminum chloride and forming salt. That salt will be CCH5NH2 plus LCl3 minus. So due to this formation of salt, then it prevents the reaction of electrophilic substitution reaction. That's why aniline does not give Friedel-Crafts alkylation and acylation. But specific aniline shows electrophilic substitution reaction under specific condition after acylation. If you do acylation of aniline, then the lone pair of nitrogen will be trapped by carbonyl group, so it prevents the oxidation of aniline. Then it gives ortho-para derivative of aniline. So this is a very important reaction. Aniline also gives, if direct sulfonation gives, similarly it gives the product. The product will be sulfonamic acid. If aniline reacts with sulfuric acid, it produces the derivative. That major product is this derivative is produced. This is called sulfonamic acid. This is called sulfonamic acid. Aniline reacts with sulfuric, concentrated sulfuric acid, produce sulfonamic acid. So these are some important reaction of aniline and aromatic aniline, that and also aliphatic amines, and their test distinction between primary and secondary and tertiary. Another important reaction shown by aniline, that is coupling reaction. Okay, what is coupling reaction? We will discuss now. Coupling reaction, like phenol chapter also you have read, that phenol reacts with BDC, benzene diazoxide chloride, forming orange yellow dye. orange color dye. Here same, if you take aniline, this is your aniline, that is all derivative of aniline also gives same reaction with BDC. With BDC, aniline with BDC forming that orange yellow dye like this. Here N2 becomes like this, then it will be attached at para position. This one, this is yellow color, yellow dye, that is, this is azo dye, this group is called azo group. So formation of azo dye occurs and the color is yellow. But in case of phenol chapter you have read, phenol reacts with BDC, this is BDC, benzene diazoxide chloride, this is aniline, and forming yellow or a yellow dye, that is azo dye, indicates the presence of aniline. This is also important test of aniline. You can identify the presence of aniline in the mixture, organic mixture. Okay, so this is about some important properties of aniline and amines. Okay, next class we will discuss that preparation and properties of benzene diazonium chloride, BDC. Okay, thank you.